All right. Yep. Let's talk about the bell work. First one, odd or even degree?
Even.
Even. How do you know?
Because the exponent is even number.
Yep. The biggest exponent is an even number, and so that means that we have an even polynomial. Leading coefficient, positive or negative?
Positive.
Positive. What are you looking at? Right after the equal sign. In this case, it's a 3, right? Okay. Let's do domain. We're going to skip range for right now. We'll do that after we do our sketch, and I asked you to skip the sketch because we'll do that together. Domain. These are things that I am allowed to use for x. So when I'm looking at this equation up here, 3x to the 4th minus x cubed plus 5x squared, is there any number that you can think of that you could type into your calculator that if you put it in for x, if you substitute it in for x, your calculator would just be like, meh, can't do it? No. Negative infinity to positive infinity. Any number that you can think of that you could type into your calculator, you could use in here for x. Negative infinity to positive infinity is another way of saying all real numbers. It covers all of our negative numbers and all of our positive numbers. All right, we'll come back to range in just a moment. Let's do our end behavior next. When I'm looking at the beginnings of these math sentences, the parts before the comma, how would I read those in English? How would I translate that? What does it mean? I see as x, arrow, negative infinity. What does that mean?
It's going up or down.
I want to answer whether it's going up or down. That part is going to come back here. F of x means I'm talking about my graph, which side it is. So as x with the arrow and the negative infinity.
It's the left side.
It's, how do you know it's the left side?
Because all the negatives are on the left side.
All the negative numbers are on the left side on the x-axis. What is the left side of our graph doing?
Going up.
Going up. How do you know?
Because if the degree is even, at least from positive to negative.
Yes. So right here, we have our degree being even, and so my ends go the same way. X with an arrow and then plus infinity means what?
It's talking about the right side.
Talking about the right side. And you said this side is going which way?
Up.
This side is also going up. How do we know this one?
Because positive.
Yes, this comes from our positive leading coefficient. All right, sketch time. And from our sketch, we will determine our range. I'm going to go all the way back to the original equation. So I've got 3x to the 4th minus x to the 3rd plus 5x squared. Is there anything that can come out of all three pieces? One can come out of all of them. Anything else?
The x
How many x's can come out?
squared.
X squared. All of them have at least an x to the 2nd power. So I can take an x squared out. What would that leave me with? 3x squared. Yep, negative x or minus x plus 5. Beautiful. X squared is a factor all on its own. I can take x squared and set it equal to 0, and I know exactly where it's going to touch the x-axis at. If I take x squared and I set it equal to 0, what would I need to do to both sides now? How do I get this to be just x instead of x squared? Radical. I've got it set equal to 0. I did the equal to 0 part already. I get that x equals 0. So I know it's going to touch the x-axis at the origin at 0, 0. I could go ahead and put that point on there right now. This is going to be a double root. How do I know that? Not because it's 0. Where did it come from? Because of the squared right here. It was x squared that I set equal to 0. Anytime we have a factor that's squared, it's a double root. So I'm going to make a little note for myself right here. This is a double root. That means it's going to bounce right there. It's not going to go all the way through the x-axis at this point. It's going to bounce like this. I need my other zeros, my other roots, so that I know where else to put these points so that I can graph my little function here. So I have 3x squared minus x plus 5. I can set that equal to 0. What kind of equation is that when I set it equal to 0? It's general form of what type of equation? Quadratic. How do I solve quadratic equations? Yep. We can try to factor it. We might need to find the discriminant if we have to use quadratic formula. Let's try to factor it and see what happens. What's a times c? 15. What's b? -1. What numbers do you know of that'll multiply to positive 15 but add to -1? There aren't any. So this isn't going to factor, which means I'm going to have to do what with it? Quadratic formula. If I can't think of anything that multiplies and adds to those pieces, quadratic formula is my only option. So we are going to do the discriminant first. I do the discriminant first for 2 reasons. One, it tells me what kind of roots I'm looking for. I'll know whether they're imaginary or real, and I'll know how many I need. Second reason is because then when I go into substitute into quadratic formula, there's a lot less to substitute in. My discriminant is b squared minus 4ac. So what am I squaring? -1. Minus 4 times a. 3 times c, which is 5, yes. What is -1 squared? 1. And then this is going to stay a minus. How do I know it's going to stay a minus? Yeah, -4, and then I've got a 3 and a 5. What's 4 times 3? 12. -12, technically. Times 5? So I have 1 minus 60. What does that tell me? 2 imaginary roots. Do imaginary roots touch the x-axis? No. This means no more x-intercepts. So the only place it touches the x-axis is at 0, 0. What are my n's doing? Going up. So I know that I'm not going all the way through here, right? Because it's a double root. I know my n's are going up, and I know I've got some imaginary roots. So I'm giving it some wiggles. This is just coming from my imagination here. I don't think it probably looks exactly like a parabola, so I'm giving it a weird little wiggle. But all I would care about on a sketch from you guys is the n's and the root. Now that we can look at this picture, I have a much easier time telling what my range would be here. Minimum of 0, that is the lowest the graph ever goes. What's the highest the graph ever goes? Infinity. Beautiful. Number 2. Odd or even? Odd. And it's negative. What are you looking at for the negative? Yes, right after the equal sign. In this case, it's a negative what?
2.
Negative 2. What would my domain be? Negative infinity to positive infinity. There's nothing I could put in for x here that would break my calculator. End behavior. Let's do the right side first. That's this one right here with the plus infinity. That means I'm talking about the right side. It's going down. How do you know?
Because the right side, because it's a negative leading coefficient.
Yes. Negative leading coefficient. You said the other side's going up? Why?
Because if it's odd, we waste one other.
Yes. This is odd degree. And so my ends are opposite. If my ends are going in opposite ways, doesn't really matter which side's up and which side's down.
It's not a problem.
It's not a parabola. Tell me about my range. It's going to be negative infinity to positive infinity. How do I know? Before I even get a sketch, how do I know? One side points down forever, right? So I can get any kind of negative number back out that I want to. The other side points up forever. So I can get any kind of positive number back out that I want. Negative infinity to positive infinity on my range. All right, now we're going to do our sketch, and I apologize in advance. I used the bell work that they had for all of Algebra 2, and I really should have vetted this example a little bit better for you guys. So at a certain point, I'm going to say just trust me on this, because it uses skills beyond what we've learned in Algebra 2, which means I would not ask you a question like that part on the final, okay? I apologize. I should have had a better example up here. I should have known in advance that this was a bad one. When I go to this original problem here, negative 2x to the 5th plus x cubed minus x, is there anything that they all have in common? They all have an x. So I can take an x out. Is there anything else that I would want to take out? I can't take out an x squared because that last term doesn't have a squared with it. The negative. Anytime I have a negative leading coefficient, I like to take that out. I can't take a 2 out of everything, but I can take the negative out of everything. What would that leave me with then? 2x to the 4th. Yep. It's actually going to be a minus x squared because remember, I'm taking the negative out, so it's going to change the sign. And then what would I have at the end? Plus 1. All right, so negative x is a factor. I can take negative x and set it equal to 0, which means x is what? X is 0. Because is there any such thing as negative 0? No. There's also nothing that exists that's called positive 0. 0 is the dividing line between my positive numbers and my negative numbers. So here I have a root at 0, 0, just like on the other one. And here's where you got to trust me. This part over here has no real roots. All 4 of these roots are imaginary. You guys haven't learned how to solve 4th degree polynomials if we don't have a GCF that we can take out. But my fast answer is that it works the same way quadratic formula does. If I were to look at this and ask you, let's just pretend this is a squared and this is just an x. If I wanted to find the discriminant, b squared minus 4ac, I would be doing negative 1 squared minus 4 times 2 times 1. So 1 minus 8, which would give me what? Negative 7. So I have x squared equals negative 7. Well, more importantly, if I take a number and I square it, can I get a negative?
No.
No. That's how I know that these all have imaginary roots. It works off the exact same way we would do quadratic formula. It's called a quadratic type. It's the type of thing that you would learn how to do if you guys go on to pre-calculus. I should have made sure it was a better problem here. However, now that I know that all 4 of these roots right here are imaginary, do I have any other x-intercepts that I need to plot? No. So what would my sketch look like? Not ever at all? One time, just right here. Is it going to go through or is it going to bounce like over there? How do we know? It's negative. Is that what makes it bounce or not bounce?
No, it's the double.
It's the double. It's the squared that would make it bounce or not bounce. Does this one have a squared on the x?
No.
So is it going to go straight through?
No.
Yes. What's the right side doing?
It's going down.
It's going down. So over here, it's going down. I gave it some kind of a wiggle just because it's my imagination. The other side is going up. Again, these wiggles right here, that's just my imagination. I don't know what these imaginary roots look like, so I'm making it up. What I do know is that the right side goes down, the left side goes up, and it's got an x-intercept at 0, 0. All right. Other than the fact that this one was horrible and had those imaginary roots, do you guys have any questions for me on the bell work? Okay. You guys have the remainder of our class period today to work on the Units 1 and 6 review, which is due tomorrow morning. Your big fall final exam review is due tomorrow night. Because your exam in here is when? Wednesday. When on Wednesday? Yeah, bright and early, first thing. You will not go to your first period class on Wednesday. You will come here. What are you allowed to use on your final? Any notes that you wrote. Does that include your book? Yes, it does. Does that include test reviews? Yes, it does. Does that include any other notes that you have written down? Is there a restriction on how many pages you can have? No. You get as much as you want. What do you need to make sure is true then? You wrote it, and you can find what you're looking for. On Tuesday night, tomorrow night, I would recommend sitting down with your notes and going through this, if you haven't already. Treat it like a practice final exam. Any problems that are on here, you want to make sure that you know where to find those in your notes. If you guys need sticky notes from me, I got a whole pile of them over there. If I run out over there, I have more. Take as many as you'd like. That would be great in your book for things that you've already written down. One other thing, I did put together a page. Well, I'm lying. I got a page from somebody else who put it together. From another Algebra 2 teacher of information that you might want to include in your notes. Who made this page though? Was it you? No, so if you want to use this information, what do you need to do with it? You need to write it down. I'm giving it to you. If you add it to your notes, you can write it down. You can't use this printed page though. Take it and pass it across for me. All kinds of really useful information on here. Important information for absolute values, square roots, long and synthetic division, factoring, solving. We've got the parent tables for the different functions that we've talked about. What formulas do I give you on the final exam? None. So if you want quadratic formula, you need to make sure that it's in your notes. It is in your book. You can put a sticky note on the page where it is in your book. Anything that you want to use on the exam, make sure that it's either in your book, on some kind of paper that you wrote, or it's on a test review. Yes, ma'am.
I know we have some questions on panels. Will we get those answers later? Or since they're multiple choice, we don't need to?
You should, if they're multiple choice, you should get them when you submit.